Hello, in this video I'm going to be talking about neural network, in particular about error backpropagation. So error backpropagation is a computational technique that we use to train our neural network model. Error backpropagation allows us to calculate the derivative of each of the loss function with respect to each of the parameters. So this is particularly useful. So first of all, our neural network model will conduct a forward pass. So in our input layer, so let's say we have L layers here. The number of layers is L, and A0, which is our input, goes into the layer 1, and Z1 represents the pre-activation. This goes into the activation function of the first layer, and then our first layer outputs A1, which is in turn input to the second layer, and so on, and we finally get to activation of the last layer, which is the output layer, which is a Y prediction. And using Y prediction and Y prediction, Y hat is our predicted value, Y is our actual label, actual value. Using that we can calculate the loss. The reason why we need backpropagation is when we want to optimize our parameters. So the update rule for our parameters is we use what's called gradient descent, and the update rule. So this is part of a gradient descent. So we want to find the parameter W that minimizes our loss function J. So our update rule is, for example, in any N layer, WL is WL minus alpha, the loss of the derivative of the loss with respect to WL. So we need to calculate WL, and the reason why it's called backpropagation is we propagate backward, whereas in the forward pass we propagate in the forward direction. The reason why we need so for any layer, so we take this layer L, any arbitrary layer, and we calculate derivative the cost with respect to WL, BL, AL minus 1. They all depend on DZ L, as you can see here. And to calculate DZL, we need to DZL is, in other words, the derivative, the cost with respect to ZL, which is a pre-activation, and it requires us to calculate DAL and G prime ZL. This corresponds to this. Well, we can calculate this very easily, but this actually requires the use of what's called chain rule, because unless it's the output layer, there are many operations between the output or the loss and AL. So we need to take into consideration all those variables in between. And so for example, we want to calculate the cost, the derivative cost with respect to AL minus 1. First of all, okay, so we want to calculate, so let's take into consideration the layer here, L minus 1. We want to calculate the derivative J with respect to ZL minus 1, which we will need to calculate the derivative with respect to DWL minus 1, BWL minus 1, AWL AL minus 1. So this is essential for calculating the derivative of each parameters, which we need in our update rule. Here we can see that simply this is applied. So as we've seen here, we need to multiply DAL, which is the derivative of the cost function with respect to AL, multiplied by the derivative of the activation function on that layer with respect to ZL. So here we consider the layer L minus 1. We are doing just that here. And this part is pretty simple as long as we know AL minus 1. We can easily calculate this part. But this part is fine. We only need AL minus 1 and ZL minus 1, and we can do that. This part actually requires inputs in the backpropagation inputs from the subsequent layer. So from layer L, which is the upper layer. So here we are applying the chain rule. This is how it works. So this is generally 안녕하세요. So we need the derivative from the upper layer to actually calculate. So first, let's look at this. So we calculate the derivative with respect to the output, the derivative of the cost function with respect to the output of the upper layer, which is our prediction y hat, and we have that, and we can calculate the derivative of the activation function of the upper layer with respect to our pre-activation. So that's DAL, DZL, and now we calculate DZL, DL minus 1. So it's the derivative of our pre-activation with respect to the input to the output layer. So the derivative of this with respect to the input to the output layer, and lastly, it's specific. This is specific to the layer of our interest, L minus 1, where we calculate the derivative of the activation of L minus 1 with respect to the pre-activation of L minus 1. So in sum, what we need here is we need the inputs. I mean, it's a bit strange to say inputs, but we need the derivatives from the previous subsequent layers to calculate the derivative of derivatives of that layer. So it's called backpropagation. We're propagating backward direction. So it's not just we can't just calculate derivatives from that layer only, but we need to take things from the subsequent layers. We use the things from this layer to calculate things from the previous layers. So that's backpropagation.